Hello everyone, I wanted to give you an overview how to do the calculation for the molar mass using the data provided for you. This is the data that was collected while doing the experiment shown in the video. And you're given on the first part, the report sheet 1, the freezing point of water taken at different intervals in time and the temperature to record the freezing point of water itself. So this data will be input into Excel to create a graph so we could accurately read the freezing point of the solvent. In part 2, an unknown was added to water, creating a solution, and the temperature was recorded at various points in time, as shown in the data here. The mass of the unknown used is 1.361, and the mass of water used is 16.345. Both of these numbers are important and used in the calculations to find the molar mass of the solute, which it's an unknown and we could determine it afterwards, the molar mass. So first part, we will take these numbers and input them into Excel so we can create a graph and find the delta T of the solution. So we will look at the Excel and how to create a graph. So all those numbers that you've seen on the previous data sheet are here. I've input them into Excel. So you're going to select them and insert the graph from the graph options. Click a scattered graph so you could work with it on your own liking. Okay, so here we created the graph. We're going to introduce the title for the axis, and we're going to record that. Okay, so we have temperature, minutes, and here we have, excuse me, going too fast. Okay, the bottom axis we have time, and for temperature the units are degrees Celsius. Okay, so I'm going to call this chart. Okay. Versus time of pure solvent. Okay. You could also, if you wanted to, here. Okay. So this is our graph. You could put a line through it if you want, work on make it more, okay. But it could clearly help us see and determine the freezing point for the solvent, which is water, okay, and from the data as well, is 0.1 degrees Celsius. Okay, we're going to do the same thing for the solution. So I'm going to select the data. I'm going to repeat what I did on the previous one. You could, okay, I'm going to go to insert, and from the graph, I'm going to select scattered graph. So what I did, so I'm going to repeat. I'm going to go to insert, come to the graph section, scattered, and I'm going to click scatter graph. Okay. Once the chart is selected, you click on the plus button, and I want to add axis titles so I could label what I have. Okay. So for this graph, what we actually have for the title is temperature versus time of solution. So in the axis here, we have temperature in Celsius, and on the bottom we have time in minutes. You could put a line through it if you would like, but now you could also leave it like this. So the data as well as the graph, you can visualize that it shows us the freezing point, okay, which if you put on the graph exactly, it's below 0, okay. So if I click on any of the points, it would indicate to me what that is, but you can notice that it's constant here at, so from the graph, you see the constant, the temperature freezing for the solution is negative 0.8 degrees Celsius. Okay, so you could also see data from the data, but the graph clearly shows this much better. So now we can find, with those numbers, we can find the change in the temperature for freezing, which is the temperature for freezing of the solvent, minus temperature for freezing of the solution. So we're going to use our numbers from the graphs. Okay, so for water, this is what we recorded. Okay, we recorded 0.1 minus, so we have 0.9 degrees Celsius. Okay, for the delta T. This is what we're going to use for the calculations. Okay, so let's write out the calculation. Okay, so we're going to take that number and put it in to perform the calculations. And to perform the calculations, you are simply doing in the calculation part 3 of the data, which is page 53 in your lab manual. So you're showing the graphs as I showed you, and then to do the calculations of, okay, the unknowns, you're going to find the molar mass of the unknown. And to do that, we're going to use delta T for the freezing. It's constant, which is 1 in our case. We calculated this. So we determined from the graphs, which I showed you before, that this is 0.9 degrees Celsius. From this equation, we're going to calculate first molality. Okay, so I is 1 and Kf, which is the freezing point constant, is 1.86 degrees Celsius over m times molality. So we're going to calculate this. We're going to rearrange the equation. Okay, so 0.9 over 1.86. Okay, equals molality. Finding the molality will help us find the moles of the unknown solute that we added to the solution. Okay, so you do the math to find the calculations, and m comes to be 0.484 moles of solute over kilograms of water, because that's what molality means. So using molality, if I take molality times kilogram of solvent, which is the water, we can find moles of solute. You were given in the data the grams of the water. Okay, so change those. So you had the grams of the water as, okay, so we already have the molality. The grams of the water given in the chart was 16. That's how much was measured in the video and given to you. Change that to kilogram and multiply by the molality to give you the moles of the solute. Okay, so 0.484 moles of solute over kilograms of water times, divide this by 1,000. Okay, 1, 2, 3, so 10, 16018. You're able to find, and this is in kilogram, you're being able to find the moles of the unknown solute. Okay, which is and once you have that, you can find the molar mass of the unknown, which is simply grams over moles. The grams again were given in the data, how much you initially measured of the unknown. We calculated the moles of the solute and you can find the molar mass of the unknown. So this is how you will perform the calculation for the molar mass of an unknown solid. So your objective is to do the graphs in Excel, just as I showed you, and complete the calculation for part 3. So not other parts, just part 3, because that's what is shown in the video, the unknown. Okay.